Okay, so we're going to make a start now. Thanks for coming to my talk. It's late on Friday afternoon. I'm sure you're all ready and willing for the wrap-up, but hopefully I can inspire you with some ideas that are pretty new this morning. Scott Guthrie obviously gave some fun demos on some of this morning, so maybe you're inspired by that. But yeah, serverless. It's a relatively new thing in some ways. We're going to be finding out about the history of it in this talk. And it's become an incredibly exciting thing for a whole bunch of teams and a whole bunch of individuals. I started using some of this technology about 2.5 years ago in a big way when I was managing some teams at an ad tech company in New York, where I live. I have a bit of a strange accent. I'm from this country, but I've lived in New York for 12 years. So yeah, I've been using it about 2.5 years in a big way. And then when I left that ad tech company, I wrote this article that's on Martin Fowler's website about serverless architectures, and it turned out to be quite popular. So much so, in fact, that I actually started my own company at the beginning of last year with my business partner, John Chapin. And what we do is consulting and training around serverless and cloud architecture. I've run a number of teams over the years. I've been an architect for a number of years, and so's John. And so we've really sort of combined our efforts to work with a number of companies around how to get their heads around this stuff. As I'm going to show you, some of this is quite new. Some of it's old, but some of it's quite new as well. And it has a whole bunch of different ideas about how we can use it to traditional systems. So what I want to go through in the session today is, first of all, a brief history of serverless. And for those of you that haven't really heard too much about the term, this will explain a little bit about what it is. This is not a sort of a pure introduction talk, but I'm going to sort of hopefully level set us at the beginning here. And then I'm going to talk about what people are actually using this stuff for. This is not just an academic technology. This is a bunch of ideas and technologies that are being very widely used in a number of use cases. And so I want to show you what some of those are and what some of the companies are that are really embracing this way of working. I want to talk about what the industry has learned so far about serverless. This is a pretty new thing, but there's already a bunch of lessons that have been learned from it. But there's also a bunch of stuff that still needs to be figured out. We're not saying, all right, we figured out what serverless is now, go forth, everybody, and use it. There are a few things that you need to be aware of that we're still trying to get our heads around. And then finally, a little bit of a look to the future, staring into the crystal ball, a few things that I think that we're going to see change over the next few years. So let's start with a brief history of serverless. And any history of serverless really has to start with talking about the cloud. And surprisingly, serverless was actually present at the birth of the cloud. And the reason it was this little thing, Amazon S3. Who here has used Amazon S3? A good few of you. OK, so Amazon S3 was launched in March 2006, one of the original Amazon AWS services. It stands for Simple Storage Service. And it's really quite an extraordinary little tool. It's a key value store. It's a mass-scale file system. And also, it's a web host. You can use it as a web server. And it is used at extraordinary scale by a huge number of companies and teams across the world. One of the most popular of Amazon's services. Amazon S3 has some very interesting attributes to it. When you're using it, you have no concern about nodes of server machines or server processes. We're not thinking about file servers when we're using Amazon S3. We're not thinking about our SAN networking provider when we're talking about S3. We're just thinking about these buckets that we can store data within, and how that data is stored on the fundamentals is really what Amazon looks after. S3 has automatic and invisible auto-scaling based upon how you use it. When you use S3, you don't say, I want a 1 terabyte bucket of S3. You just say, I want a bucket, and you're going to start using it. And the more you use it, the more Amazon will grow the storage for S3 under the covers. There's never a point where you say, oh, I think I'm going to be using an extra 50 terabytes next week, so Amazon, please, I need to tell you about that. You just use it. The costs of S3 are based upon very, very precise usage. That usage is both around how much you store in it, pretty much per kilobyte, and also how much data you have going in and out at a very, very precise level. And these costs go up as you use it and as you store things in it, and then precisely go down as you stop using it. So if you delete content from S3, your bill will be less. Another part of S3 is that performance is nothing to do with how many nodes that you have supporting your S3 bucket or any kind of machine sizing. We don't have any idea of what nodes we actually have anyway. That's completely abstracted to us. And so this whole idea of like, we want to increase the performance of our storage area network by increasing the number of nodes is just not possible because that's hidden from us. So we have Amazon basically look after the performance of S3 for us. They guarantee a certain amount of performance, and that's what we have. And there's a few little tweaks you can do with S3 to get better performances around it. But basically, it's nothing certainly around how many machines you have or how big those machines are. And then finally, here's another final attribute of S3 that's interesting, is that it has implicit high availability. For those of you who don't know, Amazon, the way that they build themselves is each Amazon sort of area is known as a region, and each region has a number of data centers, and each of those data centers is called an availability zone. Amazon will automatically replicate your data in S3 across availability zones. So for example, if one of the data centers goes down, your S3 data is still available from another data center because Amazon guarantee high availability for S3 across data centers. You don't do anything, there's no configuration to turn that on, it just happens. So these are a bunch of interesting attributes when we think about file storage and storage in general. But this is actually my definition of a serverless service more than just S3. So when you're thinking about serverless services, think about these 5 points, and those are the kind of attributes that you should expect from a product that calls itself serverless. Now, a serverless application and a serverless architecture is just one that uses these serverless services. So an application that makes extensive use of S3 could argue to be a serverless application. And there's a bunch of other serverless services that I'm going to talk about as we go through these next few slides. So I want to give you some history of how serverless sort of came about. Obviously, we just talked about S3 from 2006. I'm in London, so I have to talk about this product called Zimkey, which was created by a team that was headed by Simon Wardley, who's a fairly famous speaker in London on serverless subjects. They created this in around 2005, and it was very much a serverless compute service. It didn't end up going anywhere, but it was really sort of revolutionary and ahead of its time. Now, what wasn't ahead of its time was Amazon Lambda, which came along in 2014. And Amazon Lambda is basically serverless compute as S3 is serverless storage. All of those attributes that I just talked about apply to Lambda as well. Very precise billing. You're not thinking about where your code is running in terms of individual nodes and servers. And the implicit high availability as well. You don't have to worry about a data center going down. Lambda will automatically run across data centers for you. Now, this whole area of Lambda and Zimkey a little bit before it is what we call functions as a service, or FaaS. And there are a number of functions as a service products out there apart from Lambda. Microsoft Azure have Cloud Functions, which Scott showed this morning. Google have Google Cloud Functions. And there are a number of others as well. Beyond just compute, though, we have some other interesting services that fit under this serverless criteria that are sort of a little bit of higher level of abstraction. So one interesting one is this product called Auth0. So Auth0 tries to take all of that code that we normally have to write when we're thinking about user sign-up and user sign-on and all that kind of password management stuff, and really just encapsulate that as a service that we can just let us users access just by putting some simple JavaScript on our web pages or some simple code in our mobile apps. And Auth0 handle all of the server-side storage and logic and OAuth integration, all that stuff for you. because that's just a very common thing that hasn't got much differentiation across products. And when we think about that as a serverless service as well, again, because when we're using Auth0, it's something that we use that we have no concept of what the servers are. Yes, there's servers running Auth0 somewhere, but they're completely abstracted from us. Another example here is Firebase. Who here has used Firebase? Anybody? Very few of you. Firebase is a database that's owned by Google now. It's actually developed and then bought by Google. And it's really sort of this high-level database that mobile developers can use, and other people as well, but it's very popular with mobile devs. Because it's a database that runs without any database administration. And it also doesn't need an application server-side running on top of it. You can just perfectly safely access it from a front-end client. Firebase is similar to another product that used to exist called Parse. Parse is really sort of the forerunner in this area. Parse got bought by Facebook and then closed down, but Parse did this job very well. And there's also a whole bunch of other Amazon serverless services. SNS, their simple pub/sub messaging system, is a very, very popular one, and a whole other bunch besides. And we group all of this second group into this area that we call backend. Oh, sorry, I got my slide wrong here. We're called backend as a service, or BaaS. And backend as a service really sort of came originally from that mobile backend. If you look on Wikipedia at BaaS, you'll see MBaaS, which is this whole area of Parse, this sort of mobile backend as a service where we can get all of these useful backend tools without actually having to manage our own databases or web servers or anything like that. And so serverless is sort of the unified world of both backend as a service and functions as a service. And that's confusing for some people at first because AWS Lambda has proven so popular that at first point some people think, oh, serverless is just FAS, it's just Lambda. And it's not. There's a lot more to serverless than just functions as a service. There's all these other high-level services as well that we can incorporate into our applications. So why the name serverless? Where did this come around from? Well, when I was writing that article about a year and a half ago, I did some research into this. And the first reference I came to, the earliest reference I could find to serverless, is this article from Ken Fromm in October 2012. And he said, the phrase serverless doesn't mean servers are no longer involved. It simply means that developers no longer have to think that much about them. Now, this was in 2012, and the phrase really started picking up traction in 2015. And that was around the time that Amazon introduced a product called API Gateway. An API Gateway does a number of things, but one thing that it does quite usefully is it allows us to use Amazon Lambda functions to implement HTTP APIs, whether they're for websites or for services. And when that happened, this whole serverless word started getting used a lot more. There was an open source framework that sort of plugged API Gateway and Lambda together in a really nice way that was called JAWS, and they renamed themselves to the serverless framework. And that remains one of the most popular open source sort of libraries and tools around some of this stuff. But we certainly saw this word sort of start picking up steam about 2.5 years ago. Now there's a whole bunch of things that refer to themselves as serverless. Some of those things I think are great. Some of those things I'm not sure quite where why they think they're using that name. And really it's sort of become this fad, which I am definitely part of. But everyone wants in, and it's not even a very good name. Serverless, well, there's still servers somewhere. Okay, it's a negative name. Okay, fine. We're just stuck with it. There's a few other people who have come up with alternative attempts at names, but this is sort of the one that's stuck. But it doesn't really matter what the name is, honestly. What matters is what people are doing with it and the capabilities that they get from it. So let's get on and talk about that a little bit more. So as I mentioned, serverless is being used widely in industry now across a number of segments, across a number of types of company. People ask me, so, Mike, you're doing consulting around serverless. What verticals are you working in? Yes. Okay, well, what size companies are you working with? Yes. And there's no sort of way that we can categorize that. I'm working with finance companies and media companies and other types of companies, and I'm working with one-person companies up to multi-thousand-person companies, and there's no real sort of distinction there. The real distinction about who is using serverless is really their appetite to try out new technologies and see if it can help them with their business. But let's go through some of them now as an example. So the first group of companies, or the first group of usage of this, is for prototypes and startups. So an example here is a company called A Cloud Guru, who actually are they're a cloud training company. So if you any of you here do AWS certification or that kind of thing, you probably use A Cloud Guru to go and watch some online videos. They needed to build a website to host all of that stuff, and they did that using a bunch of serverless technologies, and they got so into it that they now actually run a global series of conferences called Serverless Conf. But they talk about how they built their app in these talks that they give at these conferences. One interesting thing is they're a serious-sized company now. They have hundreds and hundreds of thousands of users. They have got good amount of funding, good several tens of people working for them. And they're a massive AWS user, and they need to know everything about AWS. They have no EC2 servers at all running their production stack. They are an entirely serverless backend in how they run their software. Now, obviously, they're a startup, but every company in some ways has the opportunity to do little mini startups within them. And what we see is a lot of companies of larger size trying out new product ideas using serverless because it allows them to get up and running much more quickly. And I'll go into that a little bit later on in the talk. Second class of companies and usage are websites. And some of you may have heard some scary things about things called cold starts and Lambda isn't very fast and blah, 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 blah. There's definitely some things that need to be worked around there. But at the end of the day, real websites are running their applications on serverless. Bustle is sort of the leading case study around this. Bustle are a large website based in the US. They're sort of like BuzzFeed, but targeted at a women audience. I know Steve Faulkner, he's their director of engineering, and they, in talks that he gives, he says that they're actually around the 30th biggest web property in the US. So that's a big company. They're entirely serverless. They're using API Gateway and Lambda and a whole bunch of stuff to do what it is they do, and they've really sort of built that over a number of years through painful stages, because this stuff's very new, but they're now at this position where they can use serverless technologies to move really fast in their product development. And I recommend taking a watch of some of Steve Faulkner's talks to sort of see how they work. So that's websites. On the other side of sort of server-side systems, we have this more asynchronous way of working, so data processing. And this is really how I got into using these technologies. I was working for an ad tech company. We needed to process in the order of hundreds of millions of events a day. We had some systems that were doing that. They really couldn't scale to what we wanted to do with the business anymore, and so we wanted to rewrite them. And we ended up rewriting them using API Gateway and Lambda and S3 and building a whole data pipeline. And Hearst, which is a large media company in the US, large and historic media company, they also are using this technology for exactly this same way of working. There is a talk that they gave at reInvent a year and a little bit ago, actually, that I give in the resource document, which I'll give the link to at the end, where they talk about how they build this. But they look a little bit like this. Don't try and read all the detail here. But the idea is that on the left-hand side, we have a number of sources of data coming in. We put those onto event streams, and then we can have multiple consumers taking that data and doing different things with that data, and then building up this pipeline of processing. And this is an amazingly good use of serverless technologies because this is all asynchronous. So while there is some amount of latency requirements here, most people, when they're using this stuff, are willing to deal with a few seconds here or there in how fast data gets through the pipeline. And serverless technologies are a fantastic way of building these systems for a whole bunch of reasons. I'm going to come back to this diagram a little bit later on as well. So the fourth usage of serverless that I want to talk about is operations. And this might surprise some of you because you may think, well, ops people, they're not going to want to use Lambda. They want control of their own machines, and they're never going to touch that stuff. So one example that I want to bring up is a company called Meetup, who some of you will have come across the Meetup app and site. Meetup are based in New York, where I live, and so I know a bunch of the folks there. They had a transition about a year and a half, 2 years ago, where they went from on-prem to in the cloud, and they moved their legacy applications to AWS. Now, to actually do that, they actually needed to change a whole bunch of the way that they operated their software. And so their operations team had a whole massive project, not just to the initial deployment, but how they were now going to look after this software going forward. And they ended up using a ton of serverless technology to do that. So using Lambda tied to a whole bunch of CloudWatch events, using CloudFormation with a whole bunch of what are called custom resources to do funky little deployment scripts. All of those are implemented using Lambda. And a whole bunch of other stuff beside. So they were really, this sort of serverless-oriented operations team. And this is not the only time I've seen that. I've spoken to a number of companies where it's not been this grand strategy to introduce Lambda. But someone will start using Lambda somewhere, and it'll be kind of useful, and then someone else will see that and be like, oh, that could save me some time. I'm going to use that. And you see this sort of proliferation of little bits of serverless usage appear throughout the operations of applications across a number of companies. And then the final thing, sort of similar to this, is this idea of using Lambda for glue. And this is nothing to do with the product called AWS Glue. That came out after the rest of us in this industry started using the term glue for this. But glue is the idea of there's often times where we want to build these applications that just do a little bit of processing occasionally. Maybe they're a cron job that just runs 3 hours a day and uploads a data set to a third party. Or maybe they're just something that sits in the middle and just wakes up occasionally. And oftentimes it's not worth running those on an entire server just to themselves, so we end up running 50 of them on the same machine, and then you get dependency hell between them. I'm sure a bunch of you have seen that one server that has 50 slightly related cron jobs on it. And that always turns into a bit of a mess. And so what we also see being used is a lot of these sort of little tiny things are far more suited to being implemented using Lambda and other serverless technologies. And here's an example that I actually built recently. It's on our blog, where I wanted to create a build pipeline notifier for some of our own internal systems. And we're using a tool from AWS called Code Pipeline as our build pipeline tool. That generates events. Those events can be then configured to call a particular Lambda function, and that Lambda function then makes a call to Slack to put a little message in our Slack channel. That little Lambda function, I can't remember now, it's about 15 lines of code, not very much. It's really simple to deploy. I can deploy all this with one CloudFormation script. Doesn't cost me any money at all to run it. I don't worry about what machine it's on. You can download this. It's on our GitHub page. But it's very, very simple, and I don't have to think about the operations of this to any extent that I would normally do. So those are sort of 5 of the main uses of serverless that I see. So websites, prototypes, data processing, operations, and then these little glue apps that sort of sit around the company filling in some of our cracks. OK, so that's sort of the level set. Now I want to sort of talk a little bit more about what's going on in this world. And the way I got to speaking here, by the way, is I know a guy called Giles Alexander who's based here in London. And he and I were sitting down for a coffee, and I was saying, so what do you want me to do, Giles? He's like, I could do an introduction. He's like, I want a little bit more of that than that, Mike. I want to get your opinion. You've been deep in this stuff now, as deep as most people have been, as you can be if it's something that's 2 years old. Like, what is going on in serverless? Tell me. I want to hear that. So this is sort of what came out of that conversation with Giles. So what have we learned? So serverless technology is really cool. Don't get me wrong. It's really nice that I can build a tiny little 15-line function and just deploy it and not worry about coding it. And I can play around with you can do this and put that there and sort of start geeking out on all the tech. And I do that. I am a geek, so I do geek out on the serverless technology. And the technology is really interesting. But sometimes we focus a little bit too much on the technology. So here's a quote from Gojko Adic, who actually spoke this morning on a different topic, but has spoken a number of times on serverless in a really good way. And he said this in a recent talk. He said, most people are looking at serverless and platform as a service, which is a similar idea, from a technical point of view. It's far more important to look at serverless with a financial perspective. So there are many opportunities within serverless to spend far, far less money. And there's a number of places where it won't cost less money, but there are a lot of places where it will cost less money. And that's either on building applications in the first place, because it just takes less effort to put an application together. But there's also opportunity to spend less money on operating applications. So here's a slide that Gojko actually put up in his talk from October. So Gojko does a few things. One of the things he does is he co-runs an application called MindMap, which is an online mind mapping tool that anyone can use. Integrates really nicely with Google Drive, that kind of thing. They have several 100,000 users per month using their software. This is his entire AWS bill. $100 for supporting several 100,000 users. One thing on here is there are 3 cents on EC2. So he's spending 3 cents a month on virtual machines. And then his Lambda bill right down here is 53 cents. So he's spending, on his entire generalized compute, he's spending 56 cents to support 400,000 users. This is kind of revolutionary. Now, he's gone through several iterations of rebuilding their application to use a whole bunch of services. But this is quite extraordinary. I give a link to this talk in the resources, and I really recommend that you go and look at that. So how the heck does this work? Well, Gojko goes on to say this. Many of the solutions that we consider in architecture as being best practice are solutions for problems that no longer apply when we start thinking in a serverless way. So for instance, we think about high availability. And this isn't, what I'm about to give you an example now is not necessarily a cost saving, but when we think about high availability, right, we might deploy 2 versions. And maybe we do, if we're in Amazon, I'm going to speak a little bit in Amazon world. Sorry for those of you that are not AWS users. We may talk about like deploying in 2 regions, maybe. With serverless, we can deploy 5 versions of our application in 5 different regions. We can deploy our Lambdas in all of the regions in Amazon if we want. But that won't cost us any money. It will only cost us money when those Lambdas are actually executing. We would never have done that with a traditional system. Deploying our entire application stack in a traditional way 25 times around the world, that's far too expensive. We'd never do that. But the constraints have changed. And so when we start looking at a lot of these things, a lot of the constraints have changed. So we've always sort of pushed towards having the idea of a central orchestrator. And we do that oftentimes because of security. We don't want, for example, our clients, our web browsers or our mobile apps communicating directly with the database. That would be crazy talk, right? But now, that's a perfectly reasonable thing to do. The capabilities that Amazon give us from a security point of view for DynamoDB and S3, Dynamo is their NoSQL database, all gives us per request security. And the scaling that we have for those things are auto-scaled. So we don't need to worry about the sudden influx of users overwhelming our databases, because DynamoDB will auto-scale for us. And so the constraints that we have around architecture have completely changed. So this really sort of changes how we build architecture, and I want to talk about this a little later on. And we haven't figured out what that all means, but we have learned that the rules have been changed at least, and that we need to start thinking about what that means. What happens when we expand our mind and take our sort of normal view of architecture and think about things in a different way? What else have we learned? Building applications with serverless is fast, really fast. This is actually why I'm most excited about serverless. This is what got me into serverless. The cost impacts are really important and actually can be game changers for companies, whether they're starting up or whether they're companies that want to really change what they're doing, the cost implications can be massive. But this is what I'm most excited about. It's how quickly you can build something entirely new with serverless. Here's a quote from Adrian Cockcroft. Adrian is the VP of Cloud Architecture Strategy at AWS. He was the architect at Netflix that moved Netflix to the cloud. I'm sure most of you here have heard of Netflix, the big online TV and film distributor. They're an entirely cloud-based organization, and you think about the sizes of data that they're dealing with, that's quite extraordinary. They've been completely cloud now for a long time, and Adrian was the guy that sort of really moved them to the cloud. Before then, he worked at Sun Microsystems a long time. But now he's at AWS. And he said this was about a year ago at a talk. He said, we're starting to see applications be built in ridiculously short time periods. And by ridiculously short, he's talking about hours. Literally, people in enterprises building entirely new applications where they didn't exist before, not augmenting an existing app, but building an entirely new app and deploying it in a matter of hours. And the reason that this is possible, he goes on to talk about in his writing and the talks that he gives, is because people are now starting to think a little bit about building applications as sort of putting, bits of Lego together as opposed to crafting something out of clay. So with clay, you get, if you're a potter and you're putting, a piece of pottery together, you have ultimate control and flexibility. But that might take you a while, especially if you're not experienced at that. Whereas with Lego, you can build something that does pretty much what you want most of the time, and you can put that together very, very quickly using a whole bunch of standard building blocks. And that's what we're starting to see application architecture become. Not about putting together the perfect solution using tens upon thousands of lines of code and writing a whole bunch of stuff custom. It's more about taking a whole bunch of different services off the shelf and sort of gluing them together. And with that comes incredible power, and especially the power to build something entirely new very fast. Now, even if you're only building a prototype, this can be incredibly valuable. Most of the time when we're building software, we don't actually know whether we're building something that the user is going to find useful. And so if we can very quickly build a production scale, safe prototype, put that out in the world, see if users like it, we can then decide whether we need to rebuild it later using something a little bit more bespoke. But to put something out within hours is a whole amount of leverage that we didn't have before. So what have we learned? We've learned it's cheaper. We've learned that we can build things more quickly. We've also learned that DevOps is even more important than it was before. And this is sort of where I disagree a little bit with Simon Wardley, who talks about this as well. And when I'm talking about DevOps here, I'm sort of really talking about sort of the cultural side of DevOps and the collaboration side of DevOps. And so when we're talking about being able to take an idea, a concept in someone's head, and get that to production in the same day, that's not going to work if we have a 2-week-long chain of process that needs to happen from development to our operations team. We have to have either ops happening on team, or we have to have dev and ops working super closely if we're going to get that time to market benefit. We also need all of this DevOps stuff if we're going to avoid shooting ourselves in the foot. There's a lot of dynamism in these applications. There's a lot changing. So we need a whole bunch more automation and structure around how we actually operate and deploy our applications. If you want to know more about what the heck I'm talking about here, go read this book. I think this book is probably the most important in our industry for about 10 or 15 years. Those of you, who here has read The Phoenix Project? A strange little book. This is sort of the encodification of the Phoenix Project. Actually, one of the co-authors co-wrote The Phoenix Project. So I really strongly recommend going and reading the DevOps Handbook. It really sort of gets into the nuts and bolts about why DevOps is not just regular tech ops with a bit of automation. There's a lot more to DevOps than that. The good news is about some of this stuff is that DevOps doesn't, the principles of DevOps don't need to really change too much when we're using serverless. You know, I talked to some people who have seen all like these wonderful things like the demos that Scott gave today, and actually Scott used an IDE, so I'm very happy about that. But a lot of the demos you see like have code in a browser and blah, 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 and that's all you see. So people say, so what happens to source control? I'm like, you use source control. Okay, so how do we build a serverless app? I'm like, you use a build tool. Like, okay, so how do we deploy a serverless app? I'm like, you use your regular deployment tools. Like some of this stuff really doesn't change very much in the operational side for serverless, especially around the principles. Like trying to build good continuous delivery is just a pretty standard thing, both for traditional systems and serverless systems. The one thing that we do need to do with serverless and DevOps is that some of our practices need to be amplified. There's things here like we need to really change how we're thinking about the number of deployed versions that we have of an application. Normally, right now, we might have 2 production versions. We may have a blue-green production version and 1 test version and 1 staging version, maybe, something like that. With serverless, what you tend to find is you actually have like maybe many, many different production versions because it's totally free to do that. And you're trying out different segments against different versions. You may keep old versions of applications around in production to support old customers. Again, because it doesn't cost you any money. Like before, you would need to run 10 instances of the same, 10 instances of your server to support 10 different versions. Each of those would need to be running all the time. With serverless, you don't need to do that. As long as they're deployed, you'll only pay for them when they're being used. Some of the other practices we need to think about amplifying: how you do like little nitty-gritty things, like how you manage AWS accounts really needs to change when you're wanting to embrace serverless. Like this idea with AWS where you can create sub-accounts where the billing all rolls up to the company, but each account is effectively this completely isolated sort of deployment area. And that turns out to be a super useful construct to think about when you're working with these serverless apps, to have like much isolated, significantly more isolated systems between different developers or different teams. So really embracing multiple AWS accounts can be really useful when you're thinking about this stuff. But then also, you know, the book, the DevOps Handbook gets into this a little bit, but you know, thinking about areas like security and cost management. Right now, and traditionally, we sort of really left that up to different teams. You know, that's the security team's job, or you know, that's the finance team's job. Like, if we're going to start putting out new applications really frequently or massively changing the architecture of our systems really frequently, it is our responsibility as engineers to make sure that what we're doing is secure and that we're not blowing our company's budget by doing so. And so those areas of security and cost management really need to sort of shift left in the parlance of DevOps. So those are some of the things that we've learned: that it's cheaper, that we can build applications far faster, and that sort of the DevOps thing is still useful and just needs to be sort of pushed forward a little faster. But what do we still need to figure out in the land of DevOps? So here's a tweet from my friend Sam Newman from last week. Sam is sort of fairly famous in the world of microservices. He and I worked together about 12 years ago. And he speaks about serverless as well. Really great guy, really, really smart. He said this: the first-time developer experience around AWS Lambda is really bad. Once more, I'm reminded how complicated the whole built-from-primitive strategy is a problem with respect to usability of higher-order functionality. Sam is a really smart dude. He was giving AWS training courses 10 years ago. If Sam struggles with Lambda the first time he uses it, what hope is there for most people? Now, I disagree with him slightly, but I've been using Lambda for 2 years, so you know, I'm a little bit biased. But there's no question here that the first-time experience for some of these tools isn't great. I would say, to Microsoft's credit, that Azure is a lot better in this regard. The tooling that Azure Functions has is great, both on the initial experience and also the later on experience. Scott Guthrie was debugging an Azure function based on a production event from the cloud this morning, right? I've seen that demo before. I've seen that demo done using Java, where they breakpoint. It's amazing. You want to breakpoint a production event in Lambda? Good luck. You can't. You can breakpoint using SAM Local, which is Amazon's debugging tool, which is, whoa! keep that in my hand. SAM Local, which is Amazon's local debugging tool, which is a heck of a lot better than what we had available to us a year ago. But there is no ability with Amazon Lambda to debug a Lambda function from a production event. And so Microsoft are definitely better at the dev UX. No surprise, they've been doing this for 25 years. They've always been good at initial experience. And so they have got that great initial experience around. And so really, I think the other cloud vendors are really playing catch up on that dev UX side. Where Amazon win is just on like sheer scope of what you can do in the serverless world in AWS. I mean, they have far more services you can integrate with. Their scaling is off the charts. Like it's amazing when I just have a strong level of confidence when I'm using Lambda in production that it's going to be really solid. But we definitely need to fix this initial experience with serverless. So that's the first thing we need to figure out. Operations, the way that we work is largely the same. As I said, the principles and the values around operating serverless apps doesn't change. So, to some people, that's a surprise, but it really doesn't change. One of the things that we do is training courses, and the first thing that we do on our training courses is get people to set up a continuous deployment pipeline. And we do that by giving a CloudFormation template. They just run that in an AWS account, and bang, 50 people in the room suddenly have a brand new continuous deployment pipeline that doesn't cost any money because it's running serverlessly. That's just the way we work. I've been working with continuous integration systems for a long, long time. It's just how my brain works. And that does not change. The basic ways that we're working there don't change. But our tooling needs to change in the serverless world. We need to fix that. One problem that we have, and this is the same in the microservices world, but the serverless world has this on steroids, is distributed monitoring. We have far, far more moving pieces now. When you have a monolith and you want to figure out what's going wrong, you just look at the logs of the monolith. You've got all the data that you need. It's all there. When you have 25 different Lambda functions, 15 other AWS services, and possibly some other external vendor services as well, and something in there has gone wrong, where has it gone wrong? And if you're trying to trace one event that went wrong, how do you trace that event across systems? This is incredibly important to have as we grow the use of serverless. We're starting to see tooling in this area. Amazon have a tool called X-Ray, which is very early days and does not solve all these problems yet, but offers some hope. But this is a big deal. We need to think about how distributed monitoring works. We also need to think about how the specifics of deployment work. And Amazon are really pushing really hard on this in a great way. They released some stuff at reInvent, which now does automatic canary deployments for your Lambda function. So you can say, OK, I have this version deployed in my Lambda function. I now want to deploy another version of my Lambda function. And I want to slowly switch traffic from one version to the other. I'm going to give you a test criteria to figure out whether that's working or not. And if it is, I want you to slowly shift traffic from one to the other. Amazon now do that for you automatically with their tooling. That's really impressive. And that's the kind of thing that we need, because if we're deploying 30 different Lambda functions, we don't want to be running canary processes or blue-green deployment manually. And so for Amazon to give us that tooling is really solid. But we need more in the area of distributed monitoring. But the number one thing that we still need to figure out in the world of serverless is what is good serverless application architecture. So in 2003, Martin Fowler wrote a book called Patterns of Enterprise Application Architecture, which I'm sure a bunch of you here will have seen. And what Patterns of Enterprise Application Architecture did was really summarized about 10 years or so of state-of-the-art enterprise IT development. Gregor Hope came along a year or so later and wrote Enterprise Integration Patterns, which was sort of doing the same thing but for more asynchronous build systems. And both of those books are still useful today, especially Gregor's book. I still see people sort of coming to Gregor's book afresh, like 14 years on, and go, this is brilliant. This does exactly what I need. But these books were built on many, many years of experience of going and talking to a whole bunch of teams, and not just seeing one or two case studies, but seeing what patterns were working repeatedly across a number of teams, across a number of verticals. Serverless hasn't existed long enough for us to do that in the serverless world, And a lot of application architecture changes in serverless. The constraints have changed, as I mentioned earlier on. And so if architecture is different, then what are the patterns? We don't know yet. And we're going to be building that over time. Now, that's not to say that you shouldn't start using serverless. There are a bunch of really good case studies out there. And many of you will be totally happy to roll up your sleeves and go, OK, let's figure this out. We don't necessarily know the roadmap, but we're going to try this out and see what works. And that's what people are doing right now. We're still in that sort of early stage of the adoption curve. We haven't quite yet reached that chasm of everyone hating it. But we're still on that first way up. We're a little bit beyond the early adopters now, but we're certainly not into mainstream use. And so it's certainly possible to get into it. But we don't know this yet. So what do I think it's going to be? Where are we? I do this stuff all the time. I've done it for 2 years. What do I think we're going to see with serverless application architecture? I've got some ideas. So I'll go on a little bit of a rant and hand wave for you. So one of the things that's sort of really coming up as a common sort of way that people are working is this idea of sort of orchestrator-less systems, right? When we've built applications in the past, we think about having the server application in the middle of everything. Our client communicates with the server, and then the server communicates with various back-end systems to get the job done. With microservices, that's changed a little bit, maybe. We still typically have something like a back-end for front-end being at the front of everything, and then that still communicates with a bunch of other microservices. And even if we don't have that, we still have this idea of, for each business function, we have a microservice, and the microservice is the coordinator of everything that we need to do. This doesn't really necessarily fit the constraints of working with serverless systems really well. One of the things that Goiko that I mentioned earlier talks about in his talk is that he's using a pattern that we're seeing very, very frequently in now with certainly web-driven applications, where the browser makes a request to the API. For example, I want to download, I want you to convert my mind map into a PDF. In a traditional system, what we would do is the server would kick off a PDF process and then would return with a binary response containing the PDF. What we see now, much more frequently with people that sort of rewriting their systems in a serverless first kind of way, is that what will happen is the Lambda function behind that API will kick off the PDF job on some other service somewhere, and will then respond to the client immediately with a URL. And that effectively with a redirect. It might even be an actual redirect in often case. The browser then goes, oh, this is a redirect. I'm going to call this redirect. So it has a URL. Where does that URL? Does it go to another API? No. That goes to S3. It might go to S3 via a CDN, but it goes to S3. And what we can do is set up our permissions on S3 so that only that client has access to that URL for only a certain period of time. And the client can then sit there and basically poll that URL until it gives some data. Why is that interesting? Why is that useful? When we pay for Lambda functions, we pay by the 100 milliseconds. Okay? And so if we want to, in the case of this generating a PDF, the time of generating the PDF might be, say, 300 milliseconds. The time to load the PDF where it's been off of S3 into the Lambda function, that might be another 200 milliseconds, and then say it's another 200 milliseconds to return that back to the client. Our total time in that Lambda function has been 700 milliseconds. If all we do is kick off some other thing, and it's some other service to generate a PDF, and then return immediately, our Lambda function is only processing for maybe 50 milliseconds. So say we pay for 100 milliseconds. We're now only paying 1/7 of the compute costs than we would have done otherwise. And that's just sort of a minor case, but you see this a lot where people are being like, how can we move the orchestration out of the server side and either move it up into the client or build a system that is much more a choreographed network of components as opposed to one central orchestrator. So another part of this So Ajay Nair is the most senior product manager on the AWS Lambda team. I've talked to him a few times, and he gave a really good talk at reInvent last year, and I give a link to that in my resource document. One of the things he says in here about people using Lambda is he says, use functions to transform, not to transport. If you want to transport a whole bunch of data, Lambda's really not a particularly good way of doing that unless you really need to. Try and use Amazon's other technologies to do that. It is basically free for a client to upload a large file directly to S3. It's going to cost far more money for a client to upload a file through Lambda. But the Lambda functions can be used as a way of actually sort of triggering other processes or doing some transformation that you need to do. So that's why we start seeing architectures that look a little bit more like this. Instead of having one central data processing server to rule them all, which is what I've certainly worked with in the past, is we're starting to build up these networks of collaboration that we want. And there's no one server process in here. There's no one orchestrator. And this isn't new either. Sam Newman talks in his microservices book about choreography over orchestration. And in the microservices world. And I think what serverless does is it takes that and again ramps it up another level because you start seeing not just it's cheaper to do this, and it is much cheaper to use serverless systems in this way, but it makes it far, far easier to build on new functionality when you're trying to prototype something new. As a concrete example, really the reason that my business partner and I, if there was one reason that we could have to say about why we got into this, we built this brand new data processing system when we worked for this ad tech company. Processed, I'd say, on the order of hundreds of millions of events a day. So, reasonable size, not Google size, but reasonable size. There was a product team, so one of our front-end ad teams. They wanted to start capturing a new piece of data from browsers and start sort of, have an A/B test where they could do something with that and see sort of what behavior they would get. But for that, they needed to make a change to our front-end ads and also a change to our data processing. With our old system, it would have taken months. It would have involved 5 tech leads to figure out how that was all going to work and would have been something of a nightmare. The way that we built this serverless system was so flexible and so easy to add on to that it took one of our new engineers, and she joined us as a QA just a year or so before in a transition to being into an engineer. It took her 2 weeks with a little bit of time from one of our tech leads. So that was just extremely, just extraordinary what we were able to do from a developer productivity point of view compared with how we built systems before. The other thing that sort of we're seeing in the architecture side and the best practice thing is we're starting to see more about, and this is, not just for servers, but about events being considered as first-class citizens. Randy Shoup, who's the VP engineering at Stitch Fix, just wrote a really good article on this stuff, not in the world of serverless, but how are we thinking about events? Martin Fowler also wrote an article on events last year. And this is really kicking in the serverless space because we're starting to see Microsoft have their product called Event Hubs. The serverless framework have created a product called Event Gateway, where they really think that we need to be managing events as a first-class activity to make the most of serverless. This is all new. We're still figuring this out. I'm not going to say go and use one of these products right now. I'm introducing this to say this is the sort of conversations that are going on within the serverless community to try and figure out how do we use this stuff best, because this is very, very new. OK. So a little bit of crystal ball gazing now. So that stuff will have to happen. There's a little bit more crystal ball gazing. If I would sort of bet on things, I will stress that I did a blog article before reInvent in November where I gave my predictions about reInvent. I was only about 50% correct. So if I'm 50% correct on this, it's probably about right. So what we're going to see in the future, I think we're going to see some standardization and collaboration across the different functions as a service vendors. Right now, it's pretty easy to translate, for example, an Amazon Lambda function into a Microsoft Azure function. That's relatively simple to do. But wouldn't it be nice if you could just use exactly the same function on Lambda and Azure functions? I think that this might come. I think that it's simple enough that we can figure out a common interface between functions, and this may well arrive. This is sort of similar to the containers world. We're sort of starting to settle into there is a standard for containers. I think we're going to see a standard for functions as a service. I think that pretty much most teams are going to embrace at least some kind of hybrid architecture, even those that are really into running their own containers, and I'm a fan of containers in many situations. But they want to run their own servers, their long-running servers. I think they're at least going to start using more and more serverless components in what they do. Most teams already use S3, for example, for some parts of what they do. Most teams that are Amazon users. I think they're going to start using more and more of these other little bits of serverless as well, even if they're not building the majority of their app using Lambda. I do also think that open source functions as a service implementations, which I haven't really talked about because I don't really use them, are going to be a stepping stone for a number of teams here. So it's teams that are like, yeah, we like the idea of functions as a service, but we're a little bit worried by the vendor lock-in of Amazon Lambda. They might end up just using some open source implementations of FAS until they get over that point and start using Lambda. But the fastest teams, I think all teams will use serverless to some extent, but I think the fastest moving teams are going to massively exploit serverless. This is going to be a change that I think that we're going to see. And those are both the current serverless technology that we have today and a bunch of serverless technologies that don't even exist yet, like solving some of those problems that we talked about before. How do we manage events across a whole bunch of different places? That's the kind of serverless technology that's still to come. I think DevOps culture, the adoption of DevOps culture and not just of making our operations more automated. I think the DevOps culture adoption is going to be rapidly accelerated. And that's because really our processes and our culture and our management need to catch up with what our technology can now do. It used to be our sort of, we had these great processes, but our technology was slow and engineers were sitting around twiddling their thumbs. That's flipped around now. Our technology is ahead of what we can do from a cultural point of view, and so our culture needs to catch up. And once it's done that, what we're going to start seeing is this whole idea of continuous experimentation, the idea that instead of having months and months and months of roadmap, we're going to start seeing, okay, let's try and experiment, see what happens, and iterate. And we're going to do that every week or two because it's going to be so easy to try out a new idea and get it in production and get it in the hands of our users that that's going to be seen as a far more effective way of working than trying to plan 9 months out about knowing exactly what it is that our users are going to want. So to sum up, serverless is a distracting name for some quietly revolutionary technology. And I say quietly because it's actually been going on slowly for about 12 years now. It changes many of our constraints and assumptions. So don't go into using serverless just assuming that it's just a different technology platform to design the same application architectures that you've done before. I think the leading companies in 10 years' time will be the ones that are going to figure out how to use serverless the best. I genuinely think that this is going to have a significant business impact and not just a nice little sort of rounding error in engineering. And thank you very much. So if you want resources for this talk, you can either go to my Twitter, which is @MikeBRoberts. The last tweet I put gave a link. Otherwise, there's this link here. There's a bunch of, there's the slides, but there are also a whole bunch of links of talks and articles that I mentioned in the talk that I think are pretty useful.